Good evening, dear students. So, we have started Amines chapter in our previous class, right? So, we have discussed the MCQs based on the Amines chapter in the previous class. Okay, so today we are going to see the question answers. So, this particular chapter, as we have discussed, it is for 8 marks. So, you'll be getting three MCQs, that is three questions for 1 marks. Okay, each, and 5 mark, one question. So, as you know, that in chemistry, directly 5 marks question won't be asked. So it will be further divided by 3 plus 2 or 2 plus 2 plus 1. Okay. So, okay. So, shall we start? We'll wait for 1 more minute. Okay, students are joining. So then we'll start. Okay, fine. So in the previous class, we have seen, okay, so some of the IUPAC names and also those questions we have seen. So we'll continue with the same. So these questions we have seen. Okay. So okay, fine. So we'll start now. So the 2 marks questions. Okay. So with equation, explain Hoffman bromamide degradation reaction of ethanamide. Okay. What is this Hoffman degradation reaction? Here we are converting our amide. Okay, amide into amine. Okay, degradation reaction. Okay. So your amides are converted into amines. So what we have taken here, we have taken acetamide. Okay. So they have told that take a acetamide, okay, as a starting reactant. So if it can be asked generally also. Okay. Explain Hoffman degradation reaction, bromamide degradation reaction with an example like this. Okay. Or if they tell you a particular amide, okay, take acetamide, okay, or they may tell you to prepare methanamine, okay, or that is okay, directly they won't ask you that take acetamide, that is ethanamide. Okay, they can also tell you that the product form should be methanamine, or do or explain the Hoffman bromidation degradation reaction for the preparation of aniline. Okay, like that. So the question can be twisted anyhow. Fine. So see the question properly. Okay, so they have told to take the starting product as ethanamide. Okay, so acetamide, your R should be CH3. Okay, your R should be CH3. So ethanamide on reacting with bromine. Okay, so your this is bromine in the presence of alkali. Which alkali you have taken? Either you can take sodium hydroxide, or you can take KOH, or you can take what? KOH. And what it gives you? It gives you methanamine. It gives you what? It gives you a methanamine. So what will be the product? It will be CH3NH2. Okay, here it will be CH3. Just a second. O NH2. Okay, CH3, C double bond O, NH2. So this is your ethanamide, or it is also called as acetamide. So acetamide, when it reacts with bromine and sodium hydroxide, it gives you aniline, that is methanamide, plus sodium carbonate plus sodium bromide plus water. Okay, so this is our reaction. So this is the reaction. So remember this. So you have to write it like this. Okay, so see the question properly. Okay, if you do not read the question properly and if you have written any answer, okay, your answer is correct, but they have asked you to synthesize aniline, okay, and you have written this reaction. Is it right? No. Okay, it won't be correct. It will be wrong. Suppose now I tell you the same reaction, okay, with this Hoffman bromamide degradation reaction, prepare aniline, okay, prepare aniline. Can you tell me the starting products, starting reactant, students? Can you tell me what should be the starting reactant I have to take here? Okay, my product here should be aniline. Okay, aniline means what? My R should be benzene ring. Okay, R should be here benzene. So what should be my reactant here? Rest all remains the same. Okay, here only it will be benzene. R will be my benzene and NH2. This is my aniline. So what will be my starting reactant if I want to do Hoffman bromamide degradation reaction for the preparation of aniline? Yes, I want answers. Yes, please answer. You can use the chat box. Okay, there you can answer. What should be my starting reactant? Yes, nobody knows. I said you what? My R will be benzene ring. So here also take R as benzene ring. What will be the name of this? What will be the name? Okay, is it so? So this is our amide. I've taken here R as benzene. Okay, can you tell me what will be the name? What is the name of this reactant? What it is? Yes. What is the name of this reactant? It is benzanamide. Okay, it is what? Benzaamide. Okay, benzaamide. Fine. So taking benzamide, I can prepare aniline. So like this, okay, Hoffman bromamide degradation reaction. So this was the acetamide preparation is for aliphatic. Okay, it is an example for aliphatic. And benzanamide, we are giving an example for aromatic amines. Okay, so we are preparing our aromatic amine, that is aniline, from benzanamide. Okay, from benzanamide as our starting reactant, we are preparing our product aniline. I hope it is clear. Yes, I hope it is clear. Yes, shall we proceed further? Yes, Huffman bromamide degradation reaction is clear, students. Is it clear? Okay, fine. So moving forward, next question. Write the equation for the conversion of aniline into phenyl isocyanide. Okay, name the reaction. So write the equation for the conversion of aniline into phenyl isocyanide. So what is our aniline? Aniline is C6H5, okay, and NH2 or NH2 substituted benzene. Okay, so this is our aniline. So what we are doing, we are converting our aniline into a isocyanide reaction. Okay, a isocyanide. Anilines are converted into isocyanide. So which is this name reaction? It is nothing but our carbylamine reaction. Okay, it is our carbylamine reaction. So the question can be for carbylamines. Okay, the type of question asked is direct type of question is explain carbylamine reaction with an example. Okay, so that time you can explain the reaction. Okay, that is the equation, that is amines. Okay, RNH2, I'll write it here, RNH2 plus you have to react it with what? You have to react it with chloroform. Okay, you have to react it with CHCl3 chloroform plus a base. Okay, a strong base alkali, that is your potassium hydroxide, alcoholic potassium hydroxide. You have to heat this. Okay, you have to heat this. What you get? Your anilines are converted into isocyanide. Okay, plus 3KCl plus H2O. Okay, 3H2O. So what we are doing here? So this is the reaction. So if they ask you the question, explain carbalamine reaction. Okay, explain carbalamine reaction. So what you have to write? When primary amines are heated with a chloroform and alcoholic potassium hydroxide solution. Okay, foul smelling. What do you mean by foul smelling? Okay, bad smelling. So bad smelling isocyanides are formed. These isocyanides, they are bad smell. Okay, they have a very bad smell. It is called as foul smelling. The word uses foul. Okay, foul smelling. That is, it is having a very bad smell. So your primary aromatic amines, with the help of chloroform and your potassium hydroxide, when you heat this, they are converted into isocyanates. Isocyanates are nothing but they are carbylamines. Okay, and this reaction is called as carbylamine reaction. So when they ask you a question, explain carbylamine reaction with the example. Okay, so this is what you are supposed to write. This is what you are supposed to write. Okay, now same way, if they ask you, explain conversion of aniline into phenyl isocyanide. So what they have asked you here now, right? They have asked you here, explain the conversion of aniline into phenyl isocyanide and name the reaction. Okay. So that time what you have to write? You have to write the reaction and which type of name reaction. So aniline. So aniline, so you need to know aniline when they are converted into isocyanide, this is a carbylamine reaction. So I'll write the reaction aniline plus chloroform CHCl3 plus 3KOH. Okay. When you heat it, what you get? You get C6H5 NC. Okay. NC triple bond C it is. Okay. NC plus 3KCl plus 3H2O. And which is this name reaction? It is a carbylamine reaction. It is a carbylamine reaction. Is it clear? Yes, is it clear? So these are the things. So these are 2 marks question. Okay, we are discussing 2 marks question. So for explanation, 1 mark, and for the reaction, 1 mark. Now here, what? Name the equation. For equation, 1 mark, and to name this reaction, 1 mark. Okay. So like this, the marks are distributed. Fine. Again, if they ask you for the same question, write the formation of or how is methanamine converted into methyl isocyanide. Okay. Methanamine converted into methyl isocyanide. Okay. Can you tell me what will be my starting reactant? So carbylamine reaction can be asked in 3 ways. Okay. Direct question, explain carbylamine reaction with the example. So you can take any example. Okay. Then write the equation for conversion of aniline to phenyl isocyanide. So you have to write this equation and name the reaction. If they ask you how is methanamine converted into methyl isocyanide, write the equation. Okay. What is methanamine? Methanamine, my R will be CH3. Yes, CH3 NH2. Good. Vedvati, yes, correct. So CH3 NH2 plus react it with your chloroform and your alkali. Okay, heat it, heat this solution. Then what forms? CH3 NC. Okay, methyl isocyanide plus 3KCl plus 3H2O. Okay, so methyl isocyanide. Is it clear? Yes. Are this carbylamine reaction clear, students? Is it clear? So Hoffman bromamide degradation reaction. Okay. Please study with this examples. Okay, with the examples. So when with the so as we have discussed. Okay. So please study with the examples. Don't get confused. Read the questions twice. Okay. Read the question twice. Is it clear till here? So we have discussed the Hoffman bromamide degradation reaction and carbylamine reaction, and we have discussed how the types of question can be asked on a particular reaction. Okay. So we have discussed each 3 types of question can be asked on each. Right. Is it clear? Shall we move further? Yes. Any doubts? If you have any doubts, you can ask me in the chat box. Okay, you can drop your queries in the chat box. Okay, so we have discussed this. Complete the following equation with major product. So like this, if the questions is asked, okay, based on your name reaction. So for completing this with a major product, 1 mark question this is, okay. So they may ask you for 3 marks. Okay, 3 equations can be given. So each equation will be for 1 mark each. Okay, 1 mark, 1 mark, 1 mark. So 3 mark question directly. Or or they can ask you 2 equations. Or they may ask you 2 equations. So 2 equation, 2 marks, okay, based on the examiner, okay, how will I set the paper, but equations are to be also studied. So like this, so this we have seen. Complete the following equations with major product. So when amides, okay, when amides, that is amides reacts with lithium aluminum hydride, okay, and in the presence of water, you get what? You get RCH2 NH2, okay. It is a what? Primary amines, okay, that is primary amides are what? Reduced, okay, amines are reduced to amines, okay. It is a reduction reaction. It is a reduction reaction. Your C double bond O is converted into CH2, okay. So this is a equation. So this we have seen. Fine. Okay, again, next question here. A thalamide, okay, a thalamide is taken. So what we have done with the thalamide? So thalamide here, okay, see this particular equation at the bottom, you can see it, okay. So this particular equation at the bottom. So thalamide, you react it with KOH, okay, then alkyl halide, okay, and treat it with NaOH, okay. What you get? Yes, what you get, students? So if I write the mechanism, okay, amines, yes, primary amine you get. So I will explain you the Hoffman bromamide degradation reaction here itself. Okay. So you need no need to explain. Just I am explaining you here. Okay. It is a primary amine. So you have to write the yes. So you get a 1 mark. So this is a thalamide. Okay, so this is your thalamide. So thalamide, when you react it with KOH, okay, what happens? This active hydrogen is converted into a potassium salt of thalamide. Okay, it is converted into a potassium salt of thalamide. So how it is? C double bond O, C double bond O, then N, okay, N, K. So N minus K plus. Okay, so potassium salt of thalamide. So this potassium salt of thalamide further reacted with your alkyl halide. Okay, what happens now? Your K, okay, K will be replaced by your R. The active center is only the salt part. Okay, so see, rest all molecule remains the same. So you have to write same. So X, R. Okay, R. Now this is what? N-alkyl thalamide is formed. Okay, this is a N-alkyl because at N position you have a alkyl group. So N-alkyl thalamide. Okay, now this L-alkyl thalamide, when you react it with sodium hydroxide, okay, aqueous sodium hydroxide, what you get? C double bond O, C double bond O. Okay, here this bond breaks. Okay, here the bond, this bond. Okay, this one and this one bond breaks, and you get O Na plus, O minus Na plus, O minus Na plus, and plus RNH2. So what happens here? This NaOH, okay, your ONA, okay, 2 molecules of what is that? NaOH react. So your ONA and your ONA get attached, and your RNH2, your hydrogens will your okay react with get combined with the alkyl part, and you get a primary amine. So best method of preparation of aliphatic primary amines. Okay, you can prepare aliphatic primary amines. You cannot prepare aromatic amines from this. Okay, you can only prepare the aliphatic amines, primary amines from this phthalimide reaction. Okay, Gabriel phthalimide synthesis. Okay, moving further. Okay, between ammonia and aniline, which is more basic and why? Okay, ammonia is more basic than aniline because in aniline, availability of lone pair of electrons on nitrogen decreases due to plus R or plus M effect. Okay, so when you have ammonia and this aniline, ammonia is more basic. Okay, we can consider that ammonia is more basic because when we see the structure of aniline, when we see the structure of aniline, okay, so aniline NH2, so aniline has this lone pair of electron and it involves in what? It involves in the resonance structures. Okay, so it will undergo plus R effect. What it undergoes? It undergoes plus R effect. Okay, so it undergoes the what? Resonance. Fine, so I'll not write the again resonance structures here. So remember that because of lone pairs present on the aniline, it will involve, okay, the electron pair, the nitrogen decreases. Okay, so the availability of the lone pair on electron on nitrogen decreases because the lone pairs will be involved in the formation, this what? Resonance structure. You can see, okay, it will, the lone pair will be what? They will be moving in the benzene structure. Okay, electron density will be more. Okay, and in the benzene structure, the lone pair will be moving there. So it is due to plus R or plus M effect. So ammonia structure is what? Ammonia is three hydrogen. Okay, and uh, ammonia. Okay, nitrogen. Fine. So because of this lone pair of electrons, okay, so the density is more in nitrogen. Okay, so the density will be more at nitrogen. Fine. Okay. Next one, complete the following equation with major products. Okay, so complete this. Complete the students. Yes, complete this equation. Here you can see the what will be my starting reactant and what will be my starting product. Starting reactant here and the final product. So in between my this are bromine and NaOH, it forms you a methylamine. Okay. Further, it is treated with NaNO2. So this question will be for 2 marks. Okay, because they have asked you two products. Okay, they have asked you two products, the starting reactant and the final product. Okay, so can you tell me? Okay, Vedvati has answered it as, okay, Priyanka has also answered. The first one is acetamide. Okay, the first one is acetamide, and the last one is, what is the product? It is, so if this is correct, okay, acetamide, so I have to take it as CH3, C double bond O, NH2. This is correct. Okay, you get a, you take the starting, this is, okay, then you get what? CH3, NH2. This CH3, NH2, when you treat it with NaNO2 and HCl. Okay, so this is a diazotization reaction. So what you will get the product? What will get the product when you do diazotization? Yes. How it is compared to- So CH3. So if I do a diazotization on this, okay, aniline, so this will be N plus Cl minus. Okay, so this on further hydrolysis will give you what? You get a benzene. So this will be N2Cl will be converted into OH plus N2, okay, plus HCl. Okay, same way. So what they have given here, after you are doing the here, okay, you are getting CH3NH2. Okay, you are doing diazotization with NaNO2 plus HCl. When you treat NaNO2 with HCl, you get what? Nitrous acid, HNO2. Okay, then what you get? CH3N triple bond N plus Cl minus, right? This on further, when you treat it with water, what will happen? CH3, okay, this will get into N2, okay, plus your Cl with react with one Cl, okay, H hydrogen, you will get HCl and you will left with OH. Okay, so you get methanol. You get what? Methanol, CH3OH. Understood? Is it clear now? Is it clear? Is it clear? Should I explain it again? Just a second. I'll explain it again. See here. What is our starting? So acidamide to your methenamine is clear. Okay, so this is a Hoffman bromamide degradation reaction. Now, from your CH3NH2, okay, so your amines, they are treated with what? NaNA2, okay, plus HCl in the presence of 0 to 5 degrees Celsius. So this is a diazotization. This is what? Diazotization reaction. Okay, so this is a diazotization. So what will be the this produce? It is a nitrous acid produce. Okay, so what will happen? This your amine groups. Okay, amine group will be converted into CH3N triple bond N. Okay, plus Cl minus. Okay, so this is the diazonium salt produced. This is what? A diazonium benzene, that is not benzene, methyl diazonium. Okay, it is a methyl diazonium chloride. Okay, methyl diazonium chloride. Now here, so further when you treat it with water, okay, you have to treat it with water. So what you will get? You will get a, okay, so water, H2O. So H, okay, plus OH minus, H plus and OH minus. Now, your CH3, your OH minus, okay, your OH minus will react with CH3 plus, okay, this you can see this N2, okay, this it will be produced as N2 gas, nitrogen gas, plus we are left with one hydrogen and one Cl. So that will get combined to HCl. Okay, that will get combined to HCl. Is it clear? So what is our product? It is methyl alcohol. What is our product? It is methyl alcohol. Is it clear? Yes. Clear, students? Shall we move further? Okay, fine. Moving forward. 12th question. Arrange the following amines in the decreasing order of their basic strength. Okay, so how do you arrange the for this decreasing order? So first will be your secondary amine. Okay, secondary amine will be the more basic. We have discussed this. Then will be your tertiary amine. Okay, then so decreasing order of their basic strength. So first will be your primary amine, secondary amine. Then will be your tertiary amine. Okay, then will be your primary amine, and then will be your okay, ammonia. So this is the decreasing order. So remember that secondary amines are more what basic. Okay, then the tertiary because there is stirring hindrance, and then comes your primary amine. Okay, and then comes your ammonia. Okay, so ammonia is the least decreasing, and this is the more basic. Okay, this is more basic, most basic, and this is the least basic. Fine. Next one. Second set is given methylamine. Okay, dimethylamine. So this is a secondary amine, this is a tertiary amine, and this is a primary amine. So here also your okay, this is a first comes your secondary, then comes your primary amine, then comes your tertiary amine, and then comes your ammonia. Okay, then comes your ammonia. Your primary comes here. So this is the decreasing order of their strengths. Okay. Okay, so complete the following equations. Complete the following equation. Fine. Okay, here you see RNH2. Okay, reacted with 3 alkyl halide. What you will get? RNH2 when it reacts with 3 alkyl halide. What you will get? 3 times alkyl halide. Yes, what will be the answer? RNH2, aniline. Okay, that is sorry, primary amine. When it reacts with 3 times alkyl halides, what will be the product? Okay, so 3 times. So here what will form? R4. Okay, R4. Then your N. R4N plus X minus. Okay, R4N plus X minus. So your all the nitrogen atoms, okay, are converted into R4. So quaternary salt is formed. Quaternary ammonium salt is formed. Then your isocyanides, okay, your cyanides, when they are we are doing a reduction reaction, that is hydrogen in the presence of nickel catalyst, what you will get? How you can convert your cyanides? Okay, you're doing reduction with the help of H2 in the presence of nickel. Okay, what will be the product obtained? What will be the product obtained? Yes, so cyanides, when you do reduction, okay, you get RCH2 NH2. Okay, you get RCH2 NH2. Okay, so you are doing a reduction. You are introducing, so you're what you're breaking the bonds, triple bonds, and you are adding hydrogen. Okay, it is a hydrogenation reaction. Okay, hydrogenation reaction. What we are doing after breaking these bonds? Okay, cyanide bonds here. Okay, so this bond between the C and N, we are adding hydrogen. So when one bond broken, 2 hydrogens are added. One more bond, so here LCU. Okay, so triple bond N. Okay, now one bond you break. I'll take another color. Okay, break this one bond, you will introduce H2. Break another bond, you will introduce H2. What you will get? RCH2 and NH2. Yes. So we are doing what? We are doing a hydrogenation reaction. Is it clear? Is it clear? we are adding the hydrogen. Okay, one bond is broken, we are adding hydrogens, two hydrogen. One bond, another bond is broken, we are adding one more set of hydrogen. Is it clear? Okay. So aromatic primary amines cannot be prepared by Gabriel phthalimide synthesis. Yes, why they are not cannot be prepared by Gabriel phthalimide synthesis, students? Because aryl halides. Because when we take the aryl halides, right? So phthalimide first we have to react it with what? KOH. It is formed into a potassium salt of phthalimide. Then we are taking a alkyl halide, right? So if we take a aryl halide. If we take a aryl halide, then these aryl halide, they do not undergo nucleophilic substitution reaction. Okay, they do not undergo what? They do not undergo nucleophilic substitution reaction with the bulky phthalimide. Okay, because there is a bulky phthalimide amide ion. Okay, so due to that steric hindrance, so there will be steric hindrance. So because the aryl groups are also a bulky groups and there is a phthalimide group also. Okay, so there is a phthalimide group also. So this phthalimide is also a bulkier group. So there may be a steric hindrance. So because of that, they do not undergo a nucleophilic substitution reaction, aryl halide. So we are not introducing the aryl halide. So aromatic primary amines cannot be prepared by Gabriel phthalimide synthesis method. So like this, give reasons can also be asked. Next question. Uh, Tertiary amines have lower melting point, then they are isomeric primary and secondary amines. Okay. Why? What is the reason why tertiary amines having lower melting point? Because there is a absence of intermolecular hydrogen bonding in tertiary amines. Okay. So tertiary, because of this reason, tertiary amines have lower boiling point. Tertiary amines, there is a absence of intermolecular hydrogen bonding. Okay. There is absence of what? Intermolecular hydrogen bonding in tertiary amines. So because of this reason, they are having less or they are having lower boiling point. Okay. Next, complete the following reactions with the major products. So this also we have seen, right? We have seen this. So when aniline reacts with bromine and water, you get what? You get 246 tribromoaniline. Okay, you get what? 246 tribromoaniline. Okay. So this is a product. Then aniline, when it reacts with concentrated H2SO4 in the presence of that is at a temperature of 453 to 473 Kelvin. What is the product form? You get a benzene sulfonic acid. You get what? Benzene sulfonic acid. Okay, you get benzene sulfonic acid. Or it is called as sulfanilic acid. Okay, it is called as sulfanilic acid. Okay, it is called as sulfanilic acid. Fine. Okay. Okay. Complete the following reaction with major products. Yes. Tell the answer for this. There is a nitrobenzene. You have a nitrobenzene. So this is the nitrobenzene. You react it with tin and HCl. Okay. So this is a reducing agent. These are the reducing agent. So what we are doing here? Nitrobenzene is converted into what, students? Nitrobenzene can be converted into what? Yes. Nitrobenzene can be converted into reduction of nitrobenzene to yes. What is the answer? Nitrobenzene, when we are treating it with tin and HCl, what we get? Tin and HCl. What we get? We get aniline. Okay. Your oxygen O2. Your O2 okay, is converted into H2 because it is a reduction. What is reduction? Addition of hydrogen or removal of oxygen. Okay, so we are removing the oxygen and we are adding the hydrogen. So we are getting what? The answer is aniline. Answer is aniline. Is it clear? Yes. Okay. Acetamide, acetamide, when it reacts with a bromine and water, you get methanamine. Okay, you get what? Methanamine. So CH3NH2. Fine. Okay. 17th question. Write any two factors which affect the basic strength of amines. Okay, so what are the factors which will affect the basic strength of amine? First is the plus I effect. The first one is the plus I effect. So this will affect. Second is the steric hindrance. Okay, and the third one is the solvation effect. So you have to write any two effects. So write down this. Okay, please make a note of this. So if there is a question, write any two factors which affects the basic strength of amines. Okay, what you need to write, you have to write this. Okay, you have to write this. So these are the 3 points: plus I effect, steric hindrance, and solvation effect. So any 2 points, 2 marks. Any 2 points, 2 marks. Okay. Next question. Complete the following with equation. So if you take the, so they have taken primary amine. So this will be a what? Benzanamide. Okay, you have to take a benzamide. Benzamide, when you treat it with bromine and this is a Hoffman bromamide degradation reaction. It is converted into aniline. Aniline, when you treat it with chloroform in the presence of KOH, you do a carbalamine reaction. That is, your NH2 is converted into NC. That is phenyl isocyanide. Okay, so this is a 2 marks question. Again, this is a 2 marks question. Is it clear? Yes, is it clear, students? So these questions we have seen, all these questions, aniline prepared from nitrobenzene, how is methanamine? Okay, I'll write some of the equations now. Okay, you have to complete the following. Okay, you have to complete the following. Fine. So, so these are some of the complete the following questions. So you have to tell me. So first one. Okay, this is a nitrobenzene. Treat it with Fe in the presence of HCl, you get A. Again, this you can treat it with HNO2 in the presence of 273 to 278 Kelvin, you get B. This further treated with C6H5OH. C. Can you tell me what is A, B, C? This is a 3-mark question. This is a 3 marks question. So nitrobenzene treated with FeNHCl. Okay, I'll give you a hint. FeNHCl is a reducing agent. FeNHCl is a reducing agent. Now, HNO2. Okay, how is HNO2 prepared? HNO is prepared from NaNO2 plus HCl. Okay, and this is a diazotization reaction. This is a diazotization reaction. Diazotization reaction. Okay, and this is the further continuation part of that. This is a alcohol. It is a benzyl alcohol. Then further it is treated with benzyl alcohol. Okay. A is okay. A is aniline. Okay, good. Vedvati has answered it right. Fine. Now tell next anybody what is B now? Yes, A is aniline. Good. A is a aniline. So nitrobenzene is converted into your aniline. Correct. What is B now? What is B, students? When you do aniline, we are doing diazotization. What you get? What will be the product B? What will be the product B? Okay. B is benzene diazonium fluoride. Good. Priyanka has answered it correct. Good. Okay. Yes. Vedvati have also answered it correct. Good. So it is a benzene diazonium chloride. So what will happen here? N triple bond N plus Cl minus. Okay. So this is a what? Benzene diazonium N plus Cl minus. Okay. Okay, so this is a benzene diazonium chloride. Now, see, so now further treat it with benzyl alcohol. Treat it with benzyl alcohol. What will be the product C obtained? This will be little tricky. Okay, so this is your benzene. Okay, then N double bond N. Okay, N double bond N. And what will happen? Hydroxyazobenzene. Hydroxyazobenzene. Yes. Para-hydroxyazobenzene. Yes. Okay. So it will be N. Then here your yes. So 1 mark each. So 1 mark, 1 mark, and 1 mark. So like this, you will get 3 marks. Okay. So we'll move for the next question. So I'll write the next question. RNH2 treated with CHCl3 in the presence of 3KOH, alcoholic KOH. Yes. Tell the answer for first one. NH2 treated with CHCl3 in the presence of KOH, alcoholic KOH. What will be the product obtained? This we have done. Okay. Not six. Yes, RNC. So it will be isocyanide RNC plus 3 KCl plus 3 H2. Okay, the major product is RNC. Next. Okay. C2H5NH2 plus CH3COCl. Yes. Tell this. Yes. What is answer? Yes, students. What is answer for second one? C2H5NH2 react with acetyl chloride. Yes, you get C2H5NHCOCH3. Okay, there is a formation of amide. Okay, it is a formation of amide. C2H5 NHCO CH3. N-ethyl ethanamide. Okay, N-ethyl ethanamide. N-ethyl ethanamide. Okay, next one, general formula of diazonium chloride, diazonium salt, and which is a gas liberated when aliphatic primary amines react with nitrous acid. A 2-mark question. 2 marks question. What is the general formula of diazonium salt? And which is a gas liberated when aliphatic primary amines react with nitrous acid. What is the general formula of diazonium salt? This? It is AR. Okay. I can be this. I can write it as. Okay, I can write it as R N2 plus X minus. And which is a gas liberated? So you should write like this. Okay, R N2 plus X minus. Which is a gas liberated? Yes, it is a nitrogen gas. Okay, it is a nitrogen gas. Good. Vedvati and Priyanka have answered it right. Good. Okay. What? Okay. One more reaction. Very important. C6H5 N2 plus Cl minus reacts with or KCN. Gives you you get what? Okay, Priyanka has answered it as benzene. Okay. See here, this is a Sand-Meier's reaction. Okay, this is a Sand-Meier's reaction. What is Sand-Meier's reaction? Sand-Meier's reaction is when benzene diazonium chloride reacts with cuprous cyanide. This is your cuprous cyanide. Okay, copper is in +1 state, or in the presence of potassium cyanide, it forms you a cyanobenzene. It forms you a cyanobenzene. Okay, it forms you cyanobenzene with release of nitrogen gas. Okay, and this is known as Sand-Meier's reaction. Now, another reaction, C6H5 N2 plus Cl minus reacts with copper in the presence of HCl. What will be the product? This is a Gattermann reaction. This is a Gattermann reaction. This is what? Gattermann reaction. What is Gattermann reaction? Benzene diazonium chloride. Students, benzene diazonium chlorides, okay, reacts with HCl in the presence of copper powder. It gives you chlorobenzene. It will give you chlorobenzene plus N2 plus cuprous chloride. Okay, plus cuprous chloride. So this is a Gattermann reaction. So remember these name reaction, very important. Next reaction, C6H5 N2 plus Cl minus reacting with Ki. What it will give you? What it will give you? So I'm converting my benzene diazonium chloride. Okay, I'm reacting my benzene diazonium chloride with potassium iodide. What will be the product obtained? What will be the product obtained? What will be my product obtained here? Yes, Priyanka, yes, good. It is a idobenzene. I'll get a idobenzene plus KCl plus N2. Okay, so benzene diazonium chloride can be converted into idobenzene by reacting with potassium iodide. Okay, next one, C6H5 N2 plus Cl minus N2 plus Cl minus plus water. Okay, in the heat at 283 Kelvin, what you will get? What you will get? Benzene diazonium chloride when you treat it with water. Yes, Vedvati has answered it right. It is phenol. Okay, C6H5OH plus N2 plus HCl. Okay, I get a phenol. So if I want to prepare, there are different various reactions which can be done. Okay, there are different various reactions which can be done. Okay, on benzene diazonium chloride. Okay, on benzene diazonium chloride. Fine. So we have seen the reduction. Okay, reduction of nitro compounds, Gabriel phthalimide synthesis, Hoffman, then carbolamine diazotization, then bromination we have seen. Okay, then nitration. We will see nitration, one reaction. Sandmears, Sandmears we have seen. Getterman. Okay. What is Hinsberg reagent? Yes, what is Hinsberg reagent? What is Hinsberg reagent? How do you distinguish between primary, secondary, and tertiary amines using this reagent? Okay, one more question, important question. What is Hinsberg reagent and how do you distinguish between primary, secondary, and tertiary amines? What is Hinsberg reagent? Hinsberg reagent is benzyl sulfonyl chloride. Okay, C6H5SO2Cl. Okay, correct. Yes. Now, can you tell me how do you distinguish between primary, secondary, and tertiary amines? Yes, Priyanka and Vedpati have answered it right. Now, can you tell me how do you distinguish between primary, secondary, and tertiary amines with Hinsberg reagent? So, okay. So the test is like this. The reagent, okay, the reagent name is benzyl sulfonyl chloride. Okay. Yes. So I'll write the reaction. Okay. So amines. So reacted with Hinsberg reagent. Hinsberg reagent. Okay. So primary amines, what will happen? They form product. Okay. Product formed is soluble in alkali. It is soluble in alkali. It is soluble in alkali. Then secondary amines, what will happen? Product formed is insoluble. It is insoluble in alkali. Okay. And tertiary amines, what will happen? No reaction. There won't be any reaction. So very important question. Okay. Benzyl sulfonyl chloride. Okay. Benzene sulfonyl chloride. Okay. That is Hinsberg reagent. Hinsberg reagent. So what is Hinsberg reagent and how is the reaction with primary, secondary, and tertiary? Is it clear? Okay. Yes. Priyanka has answered it here. Yes. Primary gives is soluble in alkali, secondary insoluble in tertiary. Good. Yes. Okay. Then bromine reaction we have seen. Yes. So these are the important things. Okay. These are the important things which are to be covered from this particular chapter. Okay. One more, the coupling reaction. Okay. One more is the coupling reaction. What is coupling reaction, students? What is coupling reaction? That is azo compounds. Okay, azo compounds are there. So just go through the orange dye reaction, orange dye and yellow dye. Okay, very important. Orange dye and yellow dye. Okay. So benzene diazonium chloride. Okay, when it reacts with phenol, it forms para-hydroxybenzene. Okay, para-hydroxybenzene. That is nothing but your orange dye, para-hydroxybenzene. benzene. Okay, so this is the orange dye. So what happens here? Benzene diazonium chloride reacts with phenol. Okay, it gives you para-hydroxybenzene, which is the orange dye. Then the second coupling reaction is when benzene diazonium chloride reacts with aniline. Okay, it reacts with aniline and it forms you para-amino azobenzene, which is a yellow dye. Okay, which is a yellow dye. Is it clear? So this was another important reaction, that is a coupling reaction. Okay, so these are the important name reactions from this particular chapter. So any doubts? Any doubts from this particular chapter, students? Any doubts? Do you have any doubts? So you can ask me in the chat box. So we have completed the chapter amines. Okay. So we are left with 3 more chapters: chemical kinetics, D and F block elements, and coordination compounds. Okay. Any doubts? Okay. So I shall end the session here. Okay. So we'll meet in the next class. Thank you.